look at our warm-up, the reason why I wanted to do these problems on the warm-up is because on the test, you know, it wasn't very good for some of these problems, right? But do these problems look familiar to you? Okay. All right, so let's go over these. So mine says number 12, yours should be number 2, right? Place points on the x-intercepts of this graph. Guys, the x-intercepts are where the graph crosses through or touches the x-axis. Yeah. And -1, right? You should have 3 here. Everyone get that? That's all you're doing. Just placing a point on it. On the SOLs, what you are going to do is you're basically going to take your cursor and you're just going to go to it and click it, and then a point will appear, okay? Never, ever use their little dot thing, the dot tool that they give you. Don't click on that and go to it and put a dot because it doesn't register it, okay? You have to just go and click on it. Anyway. All right, so let's look at these. It should be 3 and 4 on your paper. It says the graph of a 4th degree polynomial is shown. Well, it says exactly how many real zeros does this function have? Real zeros means x-intercepts, right? Because they're real numbers. So how many does this one have, guys? 2. It crosses here and it crosses here. It should have just 2. Okay? Which is a 0 of the function. Well, if they give you f of x and it's written all in factored form, how do you find the zeros? Make this whole thing equal to 0, and then you're basically just doing mini equations for zeros. Okay? So you have x plus 3 equals 0, which is what? When you solve for x, what do you get? X equals what? X equals -3. -3? No. All right. On to the next one then. 2x minus 1 equals 0. Let's solve that for x. What do I do first? Good. And then you have 2x equals 1. And then divide by 2. And then x equals 1/2. Is that one of my answer choices? No. Okay, so that's out. Now the last one, x plus 2 equals 0. What do you get when you solve for x? Yeah, x equals -2. So which one? D, right? Yeah? All right, questions? Okay. So this one should be number 7 for you. So the zeros of a cubic function f of x are -1, -2/3, and 5. They want you to select all of the factors. Okay. So now you're just going backwards. You have x equals -1, you have x equals -2/3, and you have x equals 5. Well, guys, you found the zeros by solving for x. You get the factors by making this equal to 0. So that means you're going to get everything all on one side. So if you have x equals -1, well then just add the 1. So you have x plus 1 equals 0. There's your factor. Yeah? So that factor, x plus 1, well, there we go. Okay? And on the SOLs, what you would do is you would just go and click on that, and it should just get highlighted. If you want to deselect it, you just click on it again. Well, you guys are familiar. You've taken SOLs, right? Okay. But if you have any questions, let me know. All right, so with this one, x equals -2/3. Well, when you have a fraction, try to get rid of this denominator first, okay? So I'm going to multiply it by 3. And that goes away, yeah? Then you have 3x equals -2. Remember, you want to make it equal to 0, so what should I do? Move everything over here. Add the 2. So 3x plus 2 equals 0. Well, there's your factor. Okay? And then the last one. Guys, what is the factor for x equals 5? Huh? Okay, but how do I make it into a factor? Like, how do I make this equal to 0? What should I do? Subtract the 5, right? Remember, with the zeros and the factors, they're kind of like the opposite. If you have x equal to positive 5, then your factor is x minus 5. Okay? All right, question. All right, so if you look on your new Unit 5 assignment sheet, which is pink, the first 2 days are kind of a continuation of Unit 4. I'm calling them Unit 4B. So days 1 and 2 are we're just talking about graphs and analyzing graphs, okay? Please be aware that there is just a quiz on this, okay, on the 2 days, all right? And then after that quiz, we're going to start on Unit 5, like for real Unit 5, okay? If you look down at the bottom, second quarter ends when? No, second quarter ends February 3rd.
So 30 days from now.
Yeah, you guys have 1 month, okay? So I'm hoping that this is our schedule until the end of second quarter, okay? This pink assignment sheet. If you are concerned about bringing your grades up, please do well on the quizzes, do all test corrections, okay, and do your homework. All right.
What?
Yeah.
What happens if there's a big snowstorm?
Okay, so yes, that's a good point. If we get snow, we'll just be delayed a day. Okay. I don't know if we're gonna get any big snowstorms in the immediate future. Yeah.
It's gonna be cold.
Yeah, but if we do, it'll just, we'll just get backed up a little bit, okay? But I hope to just stay in this order. Is that clear? All right, perfect. Okay, so let's get started. Let's look at that packet that I gave you. And guys, this packet is going to be for the 2 days, so don't lose it, okay? We're gonna do half of it today, and we'll do the other half next class. So we're going to talk about polynomial functions and basically just talk about like characteristics, okay? So here are the rules. So guys, and a lot of this is not new, all right? We've talked about this before. So the number of solutions of a polynomial, okay, how many zeros that you have, right? That's going to be equal to your highest exponent, which is also known as your degree. They're the same number. All right, so they should be the same. The maximum number of terms that a graph can have, right? That's always going to be 1 less or 1 smaller than your highest exponent. Okay? But I know that's a little bit weird sometimes, so you know what we can do is we can say, it's the same as saying degree minus 1. That gives you the maximum number of terms. Okay? So here's the thing. Now we're going to talk about functions as odd or even. Okay? Odd functions are basically functions where your biggest exponent is an odd number. Alright? So for odd functions, which are, what, x, because that's x to the first, right? What's another odd number? 1. What's the next odd number? 2? No. 3?
5.
3? 3, so x to the third, that's an odd function because your biggest exponent is an odd number. And then Tom said x to the fifth. What's the next odd number? 7. So x to the 7. So if your biggest exponent is an odd number, then that means that that function is an odd function. Does that make sense? Okay. So for odd functions, basically the end behaviors, remember how we talked about the arms of the graph, the left arm and the right arm? Okay. They're going to do opposite things. They're going to go in opposite directions. Okay. If I have an odd function, I know that if one arm goes down, the other one goes up. I have to do the opposite. If one goes up, the other one has to go down. All right. For even functions, well then even functions are going to be like x squared. What else? Biggest exponent. X to the what? Another even number. 4. And then what? X to the, yeah, right? And so on. So for even functions, the end behaviors, they're going to go in the same direction. If one is going up, the other one is going, oh no, it's the same. Up, right? So when they're odd, they're opposite. When they're even, they're the same. Okay? All right. So one thing you have to know about this is your leading coefficient that always tells you your right end behavior. Okay? It always gives you the right one. And then from there, you can see, okay, am I supposed to get opposites or am I supposed to get the same? All right? And you'll see it a little bit more with these examples, okay? All right, so we're going to go through 5 of these functions, and we're just going to talk about them, okay? X to the first power. Guys, if your equation, if that function, the biggest exponent is a 1, then that means that this is a linear function. All right? Y equals mx plus b. That's a linear function because your biggest exponent is a 1. That's a line, right? So the number of zeros. How many solutions does an x to the first power have? Has to be what? The same as your biggest exponent, which is 1. Okay? If it's x to the first power, if that 1 is your biggest exponent, that means your number of solutions is 1. So what is your maximum number of terms? It's going to be your degree, your biggest exponent, minus what? Minus 1. What's 1 minus 1? 0. So there are no terms. Obviously, right? There are no terms in a line, right? So with these examples, there are 2 graphs because we're going to do one where it has a positive leading coefficient and one where there's a negative, okay? So on the left-hand side, I'm going to do positive. On the right-hand side, I'm going to do negative, okay? That means it's basically like y equals x dot dot dot, okay? I'm only putting dot 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 because I want to make up like wacky graphs. And I don't want you to think that this equation goes with that wacky graph. Okay? And the negative would be y equals negative x dot dot dot. Okay? when you go to look at the term that has the biggest exponent, just ask yourself, is the number in front of it positive or is the number in front of it a negative? That's what we're saying about this, positive and negative, okay? All right, so tell me something else, guys. Is this an odd function or is this an even function? Huh? Odd? Why? Because it's 1. Yeah, good. This is an odd function. So guys, what does that tell me? Opposite or the same? Opposite. O and O. Okay? Odd, opposite. Even would be same. So opposite. Okay? This tells me if one side is going up, the other side should be going down. And vice versa, right? So if my graph is a positive y equals x, okay, then that means that my right one should be going up. Because it's positive, my right side is going up, okay, right arm. Since this is an odd function, they should be doing opposite things. So that means my left one should be going down. Does that make sense? Yeah? Are there any terms? No, 0 terms, right? Okay, so then right arm is going up, left arm is going down. There you go. That's a line with a positive slope. Right? So let's do the same thing for our negative. Our negative friends over here. Y equals a negative. All right. Then that tells me that my right arm should be going down because it's negative. But this is an odd function, so that means my left arm should be doing what? Going up. No terms. So my left arm is going up, my right arm is going down. There you go. It's a line with a negative slope, right? I mean, this is like crazy. Just changes everything. Like, you guys have so much more knowledge about these polynomials and graphs and stuff now. Under, put it away. X squared. So guys, if your biggest exponent is a 2, this is called a quadratic. So the full unit, maybe a unit and a half on quadratics, right? If your biggest exponent is a 2, it's called a quadratic. So what does that tell me about the number of zeros? How many zeros do I have then if my biggest exponent is 2? 2. It's going to be the same, right? And guys, what's the maximum number of terms? 1. Yeah, because it's 2 minus the 1, just 1. Good. So tell me, is this an even or an odd? Even? Why?
It's 2.
Because it's 2, right? Good. So it's even, and so they do what? Yeah, the same, right? They should do the same thing, your left and right arms. All right, so let's talk about a positive one. So a positive, like y equals x squared, dot, dot, dot. And then we have a negative, like y equals negative x squared, dot, dot, dot. Okay? Oh, sorry. Can we look at this again? Second. We talked about the number of zeros, but we didn't even point out the zeros here. You know, you can have real and imaginary zeros, right? Guys, this one, your 0 is right there. 1 real. The reason why it's real is because it's actually on the x-axis. Does that make sense? Yeah? So then this one also has one real. Do you agree? Okay. I just wanted to point that out. So we can do it here too. Okay? All right, so let's see. Sorry, going back to this, a positive. Well, a positive means that my right arm is going up. And we said this is even, it's an even function, so they should be doing the same. So my left one is also going up. Do you agree? How many turns does this have? One. Okay, so this is going up, and then I have one turn, and that one's also going up. So there you go, parabola. And guys, your minimum and maximums, those are your terms, okay? So with this guy, how many real zeros do you have? Two. One, two. And that's how many zeros we need, right? So, okay, then this one's done. Two real zeros. So let's look at the negative. So if I have a negative in front of that, that biggest exponent term, it means that my my right one is going down. Yeah? Since they're even, it should be the same. So my left one is also going down, right? You have one term. Well, this one's going down. Say it look like this. And that one's going down. Okay? That's my maximum. That's my turn, right? Guys, do I have any real zeros? Does this graph cross through the x-axis? No. But how many zeros should I have? Two. So then if they're not real, they've got to be what? Imaginary. Good. Two imaginary zeros here. Does that make sense? All right. And listen, we can draw these graphs whichever way we want to for our examples for now. Okay? Any questions so far? All right. All right, so x to the third. What is another name for to the third? Like if you were to read that a different way, how would you read it? Good, cube. This is a cubic function, okay? If your biggest exponent is a 3, that is a cubic function. So how many zeros does a cubic function have? 3, good. It should be the same as your biggest exponent, right? And then what is the maximum or the biggest number of terms? Or the most number of terms? Huh? 2. Because what is 3 minus 1? That's 2. Okay? Doesn't mean you always have to have 2 turns, but it just means the most number of turns you can have is 2. You could only have 1 turn. Maybe you don't have any turns. Technically, it kind of does, but okay. So let me show you the parent function for x to the third, x cubed. Because this one's a little bit weird. All right. Is this an odd or an even function? Odd. So since it's odd, the end behaviors are going to be what? Huh? Opposite. Thank you. Good. So we have a positive example over here to the right. And this one we're going to actually do y equals x to the third. Okay? And on the right, we're going to do our negative example. And we'll say y equals negative x cubed, dot, dot, dot. We'll do a wacky one. Okay? So I'm going to switch it up a little bit. I want to start with the negative example, okay? So if I have a negative, that means my right one is going down. Since it's odd, Sabrina told us that it is opposite. That means my left one has to go how? Up. Thank you, Kevin. Maximum number of turns is 2, so it could have 2 turns. All right. So this one's up. Let's see. 1 turn here, right? 1, 2, and 3. Right? Well, 1, 2, and then we're down. Sorry. So then I have a minimum here, a maximum here, right? How many zeros do I have and what type are they? 3 what? Are they all real? Are they all imaginary? They're all real. 1, 2, 3. Good. 3 real. Okay? So that's what a cubic function could look like, right? So now let's talk about the positive, and we're actually going to look at the parent cubic function, okay? So I have positive, that means my right arm is going up, and since this is an odd function, the left one should be doing the opposite, going down, okay? So if you guys go to your calculator and you put in y equals x to the third, right, then you'll see that it looks like this, something like that. So try that, put that in and see what you get. Good, yeah, should, right?
That's really right.
Yeah, this is right. You know, do you see a clear minimum or a maximum here? No, it just looks like it kind of slithers on, right? It looks like a snake a little bit, right? So there are no actual like maximums or minimums, okay? With this one, it's like just going up the whole way, all right? Um, and with this, if you look, you see how it crosses the x-axis right there? That is your 0. You actually have 3 real zeros here because this is a times 3 situation. If you have a snake looking one that goes up and down like this, and that little curvy part, right? If you see a graph like this and it goes through that little curvy part there, just think of it as a times 3 situation, okay? Like for now, that's just good. That's good, okay? There are no real like terms, distinct terms, but this is like the parent function for an x cubed. All right? All right. So that was just a really weird one. I wanted you to see that. Okay? Any questions? Okay. All right, so let's talk about x to the 4th. So this one is called, if your biggest exponent is a 4, this is called a quartic. Okay? Let's see. Guys, I think linear, quadratic, and cubic are pretty easy to remember. But how can we remember this one, x to the 4th? Any ideas?
4 quarters of
Yeah. I mean, that's how I remember it. I remember it as 4 quarters. Like, you really need 4 quarters to get anything nowadays, right? You can't do anything with 1 quarter, right? Yeah. So, 4 quartic. Okay? So, what does that tell me about the number of zeros?
There's 4 zeros in each turn.
Good. Maximum number of turns is going to be 3 because it's 1 less than that, right? Now, is this an even or an odd function? Even. So what does that tell me about the end behaviors? What are they doing? Same. So positive would be y equals x to the fourth, dot, dot, dot. A negative example would be y equals negative x to the fourth, dot, 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 right? Yep, but it's going to have more terms, right? So my positive one means that my right end behavior is going up. And we said they're doing the same, so my left one also has to be going up, right? So let's draw this one a little bit wacky. We have to have, what, 3 terms? So 1, 2, 1, 2, right? And what, one more? 3. Are my end behaviors both going up? Yeah. Do I have 3 terms? Yeah. Pretty good, right? How many real zeros do I have here, guys? Oh, you know what? Let me wait. I'll wait so you guys can copy. All right. So how many real zeros do I have here? 2. Because they go through the x-axis. They touch the x-axis. So I have 2 real zeros. So how many zeros should I have total? I should have 4. So if I have 2 that are real, then what are the other 2? Good. 2 imaginary. Good job. So let's try the next one. The negative one. Well, that means that my right one is going down. This is an even, so they're doing the same. And I have 3 terms. We'll make this one a prettier one. There we go, an M. 1, 2, 3 terms, right? And behaviors are both going down. How many real zeros do I have? 4. 1, 2, 3, 4. Yes? All right, so the last one that we're going to talk about is x to the 5th. So x to the 5th, when your biggest exponent is a 5, this is called a kintic function, okay? How can we remember this? Huh? Quintuplet, yeah. Or in Spanish, quince. I know quince is 15, but still, there's 5 there. All right. So, number of zeros. How many zeros does a kintic function have? 5. So that how many terms? 4. Good. All right. So guys, is this an odd or an even function? Odd. So what does that tell me about the end behaviors? Good. All right. So let's set it up. We have our positive y equals a positive x to the 5th dot dot dot. Yeah. And then our negative y equals negative x to the 5th dot dot dot. Okay. Kevin, you feel a little bit better? You want to go get water? All right. So if it's positive, it means that my right arm is going up. But Sabrina told us that this is an odd function, so what is my left arm doing? Down. How many turns does this have? 4. Okay, it can have up to 4. So this one's going down. All right, let's see. 1, 2, 3, right? 4. Yeah? Do I have 4 turns? Max here, max here, local max, local min and min there. Yup, so I have 4, right? How many real zeros do I have? 1, 2, 3, 4, 5. Good. 5 real zeros. Are we okay with this? All right, so let's make the other one have some imaginary. Yeah? All right, so this one, if it's a negative, that means my right one is going down. So my left one has to be going how? Down? Is it the same? Opposite, right? So I'm going to say, okay, starting up here. So 1, 2, 3, 4. There we go. I think that's a good mix. Are we okay with this? How many real zeros do I have? 3. 1, 2, 3. 3 real. Well, if I have 3 real, how many imaginaries do I have? 2. Why? They have to add up to give you what? All right. Questions so far? Okay. I know this is a lot, but I think the hardest part is over. Okay? Let's go on to the fun stuff.
So it doesn't keep going.
Oh, yeah. Listen, it gets more and more fun. All right. So what we did was we just classified these functions by the degree. So by the exponent. We look at the exponent, we can say what type it is, right? Like x to the third is a cubic. Well, the next thing you can do when you classify these is you can classify them by terms. So how do you figure out how many terms? Well, the terms are going to be separated by a positive or negative sign. And you actually already know this, okay? All right, so the number of terms. If there's only one term, that means you don't have any positive, plus, minus. It's just x. Or it could be x to the third. Or it could be 4, whatever number, right? 3, 1. So when you have just one of those, this is called a monomial. It's going to be something nomial. Yeah. So if you have 2 terms, Tom's right, it is a binomial. Somebody give me an example of a binomial.
X squared plus 64.
Yeah, x squared plus 64. Look at that. You have these 2 terms, and they're joined together or separated, whichever, by a plus. You can also have x cubed minus 1. That's a binomial. You can have x plus 5. That's a binomial, okay? So how about if you have 3 terms, then what is that?
Trinomial.
Yeah, trinomial. See, I told you guys know this stuff. So an example of a trinomial would be
X squared plus x plus 3.
yeah. have more than 3 terms, just call it a polynomial. Or if you don't know, okay, you know it's something, but they didn't give you enough information, well then it's a polynomial.
Just like a polygon. More than.
Yeah, yep, because polygons you have like hexagons and stuff like that, right? Decagon. It's been a while since I taught geometry, but so 4 more term would be
X cubed plus x squared plus x plus 4.
all right. Then whatever example you want to give me, okay? Just has to be 4 terms, or it could be 6 terms. All right, so for the next 3 problems, we're going to classify these by the degree and by the terms. So normally we do the exponent name first and then the terms, okay? So if we look at number 1, we're going to go and get the biggest exponent that we have, which is 3. Do you agree? How many terms do you have here? 1. Okay. So let's take it one thing at a time. If your biggest exponent is 3, what is that called? First page stuff. Cubic. And then how many terms do we have? Oh, is there a plus or minus? 1, which is called a what nomial? Monomial. So this is a cubic monomial. Okay? Look at the next one, guys. What is your biggest exponent in the next one?
Quadratic.
Good, 2, which is a quadratic. And then how many terms do you have?
Trinomial.
You have 3?
Yeah.
1, 2, 3. Yep. So quadratic, trinomial. I want you guys to try the next one, please. And then we'll compare. Oh, if my biggest exponent is 5, what is that called? Quintic. And how many terms do I have?
More than 4.
Yeah,
4.
more than 3, right? So 4, and so that is a polynomial. And you know, guys, technically all of these are polynomials. It's just that 1, 2, and 3 have specific names, okay? That's not to say on the quiz you just tell me it's a polynomial, all right? If it's a monomial, you tell me it's a monomial, all right? All right, any questions about this? Okay. This one, right? I think it's out of order. Hold on, I think my notes are a little bit out of order. Here. All right, so let's describe a couple of these, okay? So number 1. So for the name, they want you to do the, the degree and the terms thing here. Look at number 1. What is your biggest exponent here, guys? 5. So what is that? Yeah, quintic. And how many terms do we have?
Polynomial.
Yeah, quintic polynomial. Oh, it's the same as the last one that we did, huh? What is the degree here? What is degree again? Check on the first page. I don't expect you guys to. Degree is the same as your what?
Your,
Highest exponent, which is?
5.
And then what is the number of zeros that this could have? 5. Same as your degree, right? And then what is the maximum number of turns here? 4. Okay? So these down here are talking about the end behaviors now. As x approaches negative infinity, Remember, if you're on the x-axis and you want to go towards negative infinity, you have to go to the left. If you're on the x-axis and you want to go towards positive infinity, you're headed to the right. That's your left end behavior, and that's your right end behavior. Okay? Guys, is this an even or an odd function? Odd. So since this is odd, it's doing what? Opposite. Okay, remember, if one goes up, the other goes down. So guys, here's what we're going to do. We need to find our right end behavior. Go and get the term that has your biggest exponent. Look at the number in front of it. Do you see a negative? Is that 3 a negative or a positive? It's a positive, right? So, since that's a positive, it means that this is going up on the right. And that means up to infinity. Does that make sense? And since it's an odd function, it should be doing the opposite. That means your left one is going how? Huh? Yeah, down or down to negative infinity, yeah. All right. You guys want to try the next one? I want you guys to try it. And then we'll go over it together because I definitely want to do number, okay, so for number 2, well, my biggest exponent is 4. So this is going to be a quartic at 1, 2, 3 trinomial. Did we get this?
Yeah.
Perfect. What is the degree, guys?
4 squared.
4. What's the number of zeros?
4.
And what is the maximum number of turns?
3.
Good. So this one is going to be the tricky one, right? Even, so it's the same. And if you go and look, that term that has the x to the 4th, it has a negative with it, right? So that means that my right one is going down to negative infinity. And then since they're even, they should be doing the same. Yeah? On there? Yes? Good. Perfect. All right. Let's look at number 3 together. So in number 3, they gave you guys the graph, right? So when they do that, you know what? Let's start with the number of terms. Okay? I mean, you could do the end behaviors. It doesn't really matter. I just want to start with the name and the degree again. Okay? So actually, yeah, you know what? Let's just start from the bottom and work our way up. Left arm is over here. What is this left arm doing?
Going up.
Going up. Up to where?
10.
Yeah. And then look at your right arm. Where's that one going?
10.
Down to negative infinity. Oh, look at this. Are they doing the same thing? No. This tells me that this should be an odd function because they're doing opposites, right? Okay. So how many terms do I have here? 2, because look, I have a min and I have a max. Yeah? So I have 2 terms. How many zeros do I have?
3.
1, 2, 3. Guys, if I know the number of turns, can I figure out the degree?
Yeah.
Yeah. If the number of turns is 1 smaller than the degree, then if I go backwards, I have to do what? 2 plus the 1. So what's 2 plus the 1? 3. Which is the same as the number of zeros, right? Sabrina, are you okay with that? So if my degree is 3, that means that, what is the exponent name for it? Huh? Cubic, good. Do you know how many terms this guy has? I don't know, right? They gave us the graph. They could have written it in, I don't know, different ways. So remember what I said? If they didn't give you enough information, you can always call it a what? Polynomial. So this is a cubic polynomial. If they were not specific, okay? Questions? No, not yet. All right. Okay, so let's talk about transformations really quickly, okay? So transformations, guys, I put two examples there because it doesn't matter if it has an x to the third or if it has x to the fourth, okay? Transformations are always going to do the same thing, right? The thing is, you guys, this is not new. If you have a plus k on the outside, how does that make the graph move? Well, but how does it make it physically move? Like, does it go left, right, up, down? Does it stretch, compress, flip? What does it do? Up or down. Plus k means it goes up k. Minus k means it goes down k. Right? Okay? So how about this? The x minus h. If you have x minus h, how does that make it move? Huh? Right, good. Right h. Remember, it's kind of like the opposite. Since it's minus h, you want to say left, but when it's inside a grouping symbol with the x, it has to go opposite. And x plus h would be then left h. Okay? All right, and then what about this a in front? If you have a negative in the front, what does that mean? Not yet. If it's just a negative, what does that do? You know what though? Since you said compress, let's talk about compress. We'll put that on there. Oh, oops. No, gotta flip it. Sorry. 0. If that number is between 0 and 1, so like 1/2, 1/3, 1/4, then that compresses, just like Kevin said. What about if that number is bigger than 1, like it was 3 or 2? Stretch. So then if you have a negative there, negative does a whole separate job. What does that negative do, Timlin? Do you remember? Hmm?
It makes it small.
That one's compressing. Like it makes it like narrower. Or no, flatter. I mean, I'm sorry. What does that negative do?
It goes opposite.
Okay, but how does that make the graph look? Like if you had an absolute value like this and you put a negative,
Like flips, yeah.
flips, good. So the technical word is reflects, but I'm gonna put flips. Okay? And guys, it doesn't matter what exponent is there, these rules still apply, okay? To like everything. So here's the thing, how do you know if a function is continuous? If you were driving on that function, you can keep driving on it, you don't have to stop, okay? It means that they do not have any holes, gaps, or breaks. Okay, and basically you could just drive on them. Or you could trace it with your finger and not move it. Okay. One-to-one functions, they pass the horizontal line test. So if you had two graphs, one graph that looks like this, one graph that looks like that. Okay? All right? The horizontal line test is basically if I took a horizontal line and I ran it through this graph, okay? Does it hit the graph in only one spot here? Huh? No, it hits it at two spots. So you know what? This one, not one to one. Okay? It doesn't pass the horizontal line test. But look at this guy. Does it pass the horizontal? I mean, it curved a little bit there, but it's really not supposed to. Does this one pass the horizontal line test? Yeah. Okay. It's just because my drawing is so bad. But this one, yes. This one is one to one. Okay, that's what that means. Yes? All right. So what we're gonna do is, I realized the first day back, we'll stop here. Okay. Please do not lose this packet because we're gonna work from it again next class. I'm gonna pass back your Unit 3 tests and test corrections. That is due January 17th. Okay?